Question number 1 in the exercise 3.4. My dear students, today we are going to apply the trigonometrical identities in the form of sum or difference. So recall the formulae: sin x plus y, sin x minus y, cos x plus y, cos x minus y, similarly tan x plus y, tan x minus y. Okay. So first thing given as sin x equal to 15 by 17 and cos y equal to 12 by 13, where x and y lies on the first quadrant 0 to pi by 2. Okay. So our aim is to find out the value of sin x plus y, cos x minus y and tan x plus y. Okay. We know the formula: sin x plus y equal to sin x cos y plus cos x sin y. So we need to find out cos x sin y. So first take the first ratio. So I am going to represent in a right angle triangle. So it is angle theta. So sin x means, so opposite side by hypotenuse. So 15 is 17. We need to find out the adjacent side. So very simple one. Root of 17 square minus 15 square. Root of 289 minus 225. Root of 64. Okay. That is 8. So adjacent side is 8. Therefore, we are getting cos x equal to, okay, 8 by 17. Similarly, take the next triangle. Okay. It is, it is not theta, x. So it is y. Okay. So again, cos means adjacent side by hypotenuse. So 12, 13. We need to find out the, so for that one, root of 13 square minus 12 square, root of 169 minus 144, root of 25, that is 5. Okay. Therefore, sin y equal to 5 divided by 13. Okay. So similarly, find out tan x and tan y. Okay. So tan x is sin x by cos x. So sin by cos is 17 cancel, we are getting, or you can find out opposite side by, what is that, adjacent side. Similarly here, sin by, okay, sin by cos, so 15 by 8, that is enough. For the second one, it is 5 by 12. Okay. So keep these values. Now our aim is to find out sin x plus y, first subdivision. So sin x cos y plus cos x sin y. So this is the identity. So use the values here. So 15 by 17 into cos y. So 12 by 13. Okay. Plus cos x 8 by 17 into sin y 5 by 13. Okay. So now we have to find out what is 17 into 13. I think it is 221. So 221. Okay. So here what about 15 into 12? 15 into 12 means I think 180 plus 5 8s are 40. So 220 by 221. It is the answer for the first subdivision. Second subdivision, cos x minus y. So what is the identity? Cos x cos y plus sin x sin y. That is the identity in the difference form. So cos x value 8 by 17 into cos y 12 by 13 plus sin x 15 by 17 into sin y 5 by 13. Obviously the denominator is 221. Okay. So here 12 8s are 96 plus 5 15s are 75. So 171 by 221. Third subdivision, our aim is to find out tan x plus y. So it is tan x plus tan y by 1 minus tan x into tan y. Okay. So what is tan x? 15 by 8 plus 5 by, okay, So 5 by 12, 15a by 8 divided by plus 5 by 12, 1 minus 15 by 8 into 5 by 12. Okay. Again 8 12s are 96. So 96. Take the LCM in both numerator and denominator. Here, what is that? 15 into 12, 180, 40, okay, divided by, here also take the LCM. So 96 minus 75 by 96. So 96 cancel. Okay. So what is the answer? 180 plus 40, 220 divided by 96 minus 75, that is 21. Two in the exercise 3.4. The question is, if sin A equal to 3 by 5 and cos B equal to 9 by 14, where A and B lies between 0 and 5 by 2, that means the first quadrant, find out value of sin A plus B and cos A minus B. It is similar to the first problem. That's why I am explaining directly from the first one. It is the angle A, opposite side by hypotenuse. So we need adjacent side, root of 5 square minus 3 square. We are getting root 16, it is 4. Similarly for the second one, it is angle B. Cos B means it is adjacent side by hypotenuse. So 41 square minus 9 square, we are getting this. The opposite side as 40. So cos A equal to adjacent side by hypotenuse from the first one, 4 by 5, and sin B equal to 40 by 41. Sin A plus B equal to sin A cos B plus cos A sin B. So 3 by 5 into 9 by 41 plus 4 by 5 into 40 by 41. Okay. So 9 3 is 27, 4 into 40, 160. So denominator 5 into 41, 205. So if we sum up, we are getting the answer 187 by 205. Similarly, we can find out cos A minus B. Denominator is same, 205. 4 9s are 36 and 3 40s are 120. So the answer is 156 by 205. Question number 3 in the exercise 3.4. The question is, find cos x minus y. If given that cos x equal to minus 4 by 5, where x lies in the third quadrant, pi to 3 pi by 2 means third quadrant. And similarly, sin y is given as minus 24 by 20y. In y also lies in the third quadrant. Find cos x minus y. Okay, first just forget the sign. Cos means adjacent side by hypotenuse. This is the angle x. So obviously we can find out the opposite side, root of I square minus 4 square, we are getting 3. Similarly, cos sin y means opposite side by hypotenuse. To get the adjacent side, root of 25 square minus 24 square, 625 minus 576, root 49, we are getting 7. So third quadrant, in third quadrant, tan alone, tan and cot positive, sin and cos negative. So when we are finding out sin, opposite side by hypotenuse anyway minus, because third quadrant. Similarly, cos y equal to minus 7 by 25. Once again third quadrant, cos negative. Okay. So now cos x minus y equal to cos x into cos y plus sin x into sin y. So put the values. So minus 4 by 5 into minus 7 by 25 plus minus 3 by 5 into minus 24 by 25. So minus into minus plus. So 4 7s are 28 by, so 125 plus 3 24s are 72 by 125. So 28 plus 72, 100 by, so we can cancel by 25. We are getting 4 by 5. Find sin x minus y. If sin x equal to 8 by 17, where x lies in the first quadrant, and cos y equal to minus 24 by 25, where y lies in the third quadrant. So obviously we have to take a right angle triangle. This is the angle x. So opposite side by hypotenuse it is given. We need adjacent side. So root of 17 square minus 8 square, it is nothing but root of 225, 15. Okay. Similarly, cos means adjacent side by hypotenuse. So we need the opposite side, root of 24 square minus 24 square. So we are getting 7. So first one, first quadrant, therefore cos x cos positive. So 15 by 17. Second one, third quadrant, okay, sin and cos both negative. So we are putting minus 7 by 25. So be clear with the sign. Okay, depend upon the quadrant, the sign will change. Okay. So now sin x into cos y, 8 by 17 into minus 24 by 25, okay, plus, sorry, here minus, okay, cos x 15 by 17 into minus 7 by 25. So 17 into 25, 425. So 8 into 24, 2, 3, okay, minus, don't forget the sign, minus 192, here minus into minus plus. So 7 15s are 105 by 425, same denominator. So we can subtract. So 92, okay, minus 5. So minus 87 by 425. Question number 5 in the exercise 3.4. There are 3 subdivisions. Find cos 105 degree, sin 105, and similarly tan 7 pi by 12. It is in the radian measurement. 5 by 12 means 180 by 12. Okay. What we are 112. So here 160. So 5 times. So 15 degree. So 7 into 15 again. It is also 105. Okay. So first cos 105 can be written as cos, convert into known values, 45 plus 60. So we know the value of 60 and each ratios for 60 and 45. So cos A plus B, cos A cos B minus sin A sin B. Cos A minus B, cos A plus B equal to cos A cos B minus sin A sin B. So 1 by 2, 1 by root 2, sin 60 is root 3 by 2 and sin 45 is also 1 by, so 1 minus root 3 by 2 root 2. Subdivision 2, sin 105, again the same, sin 60 plus 45, okay. So sin A plus B is sin A cos B plus cos A sin B, okay, taken A as 60, B as 45. So cos sin 60 is root 3 by 2, it is 1 by root 2, cos 60 is 1 by 2 and 1 by root 2. So we are getting, okay, so root 3 plus 1 by 2 root 2, okay. Similarly tan 105, so it can be written as again tan 60 plus 45, okay, or already we have cos and sin, okay. So tan 105 is nothing but sin 105 by cos 105. You can find out in 2 ways. Either apply the formula directly, 60 plus 45, tan 60 plus tan 45 by 1 minus tan 60 into tan 45, or already here we found that, okay, what is sin, root 3 plus 1 by 2 root 2 divided by cos 1 minus root 3 by 2 root 2. So it cancel. We can write this 1 plus root 3 by 1 minus root 3. We can get it directly. To simplify this, multiply and divide by the conjugate of the denominator. So 1 plus root 3 into 1 plus root 3 by 1 minus root 3 into 1 plus root 3. Numerator a into a square. So 1 plus root 3 the whole square. So 1 plus 3 a square plus b square plus 2 ab by, it is of the form a plus b into a minus b, a square minus b square. So 1 minus 3, okay. So 4 plus 2 root 3 by minus 2. So divide by minus 2, minus take it as common. So 2 plus root 3. So minus of 2 plus root 3. This is your book answer. Question number 6. There are 3 subdivisions. Our aim is to prove these equations. First one, cos 30 degree plus x equal to, this one we have to prove root 3 cos minus sin by 2. Second, prove cos pi plus theta equal to, okay, minus cos theta, and also sin pi plus theta equal to minus sin theta. Take the LHS of the first one. So cos 30 plus x, cos a plus b is cos a cos b minus sin a sin b. Okay, so cos 30 is root 3 by 2 cos x, okay, minus sin 30 is 1 by 2, so sin x, so same denominator, so root 3 cos x minus sin x by 2, it is nothing but the RHS. Very simple one, just we are applying cos a plus b. Second one, cos pi plus theta, that is the LHS, okay, second subdivision. So again apply cos a plus b formula. So cos a cos b minus sin a sin b. So remember my dear student, sin n pi is always 0, sin n pi always 0, cos n pi minus 1 power n, remember this one, sin n pi is always 0 for all values of n, cos n pi is minus 1 power n. If n is an odd number, minus 1, n is an even number, means plus 1. So here cos pi value is minus 1, okay, minus 1 into cos theta, sin pi 0, 0 into anything 0. So we are getting minus cos theta. Similarly, third one, what is the LHS? Sin pi plus theta, okay. So look at here, again apply sin a plus b, sin a, okay, cos b plus cos a sin b. Already said that sin pi is 0, 0 into cos theta 0, okay, plus cos pi value is minus 1 sin theta, so we are getting minus sin theta, that is the RHS.